Executives in 2026 face an unavoidable operational reality. They must transform their organizations using AI or lose their competitive position to those who do. McKinsey research shows that while this pressure is universal, successful execution is rare. Only 30% of initiatives deliver the value leaders expect. The remaining 70% represent initiatives that stall or derail, leading to significant losses in enterprise value and wasted capital. These failures are rarely caused by a lack of access to high-performance models or raw computational power. The problem lies in treating AI as a simple software patch, attempting to layer automation over legacy systems that were never designed for it. Sustainable advantage depends on organizational speed and the structural depth required to apply technology at scale. Acquiring AI tools is merely the cost of entry. The return on investment comes only through deep structural integration. Foundation models and compute power have become commoditized. They form a flat, uniform baseline across the entire corporate landscape. Every major competitor in your sector has access to these same tools, meaning the technology itself no longer provides a point of differentiation. While legacy firms build directly on this flat layer, leaders rebuild their internal systems to support a new kind of operation. This structural evolution results in a rewired enterprise, designed specifically to capture value where others find only costs. Rewiring requires the systematic restructuring of every core business process, from HR to supply chain management. Processing enterprise data at this scale requires rigid physical architecture, rows of servers capable of handling massive, continuous workloads. When an organization is rewired, its capabilities build off one another, creating a compounding value that increases competitive distance over time. Market winners build organizational systems that multiply the value of the technology they buy. Analyzing a successful enterprise requires us to view organizational design as a precise engineering problem. Beneath the surface of daily operations are 6 foundational capabilities: strategic road mapping, talent, the operating model, the tech stack, data pipelines, and adoption. These gears must operate in perfect tandem. If they are siloed, the organization cannot generate the momentum required for transformation. Strategic road mapping sets the direction, while a deep talent pool provides the technical expertise to build the necessary tools. The operating model defines how people work, supported by a tech stack that allows for modular, scalable deployment. High-quality data pipelines feed the system, and adoption mechanisms ensure that new technologies are integrated across every department. Attempting to bypass these foundational requirements causes the entire system to jam. Without all 6 gears, the transition from pilot to scale inevitably fails. Mastering these 6 capabilities is the prerequisite for moving into the next phase of enterprise technology. This phase is defined by agentic engineering, the design of AI systems capable of autonomous planning and execution. Traditional software follows a rigid, linear path. An agentic workflow uses a dynamic network that branches and self-corrects based on real-world feedback. Modern foundation models can now perform sustained, autonomous work over long periods, initiating and completing tasks without constant human intervention. In software development, these agents handle the entire write, test, debug cycle independently. This compresses weeks of manual coding and troubleshooting into hours of autonomous iteration. Deploying these autonomous models within a legacy organization is dangerous if the underlying rewired foundation is missing. Without deep integration, autonomous workflows can create systemic risks that move faster than a human manager can monitor or correct. Only organizations that have mastered the 6 foundational gears can safely deploy this level of autonomy. Agentic engineering converts AI into a proactive operational agent, accelerating the base speed of the entire enterprise. The agentic playbook begins by ingesting vast streams of unstructured data and organizing them into a focused operational flow. The foundation model uses this data to identify patterns and initiate business tasks without waiting for a manual prompt. Safe operation requires rigid control structures. Automated guardrails must be built directly into the system to define the perimeter of the AI's autonomy. These boundaries enable speed. They allow the data flow to accelerate safely, ensuring the AI operates within the company's risk tolerance. Within these guardrails, teams conduct rapid experiments to identify the most efficient autonomous workflows. Successful experiments are then codified into a repeatable, enterprise-wide playbook for all agentic operations. This engineering discipline separates professional transformation from organizations that simply hope for results from new software. Success in agentic engineering depends on the automated containment structures that allow the business to run safely at speed. Beyond the software layer, the enterprise must navigate constant macroeconomic shifts and technological disruption. In many optimized systems, the primary bottleneck is the human control node, the C-suite. As innovation accelerates, the relevance of established executive skills decays. This curve shows how quickly technical and strategic knowledge trends towards zero. The pace of innovation rises simultaneously, creating a dangerous gap between a leader's existing knowledge and what the system requires. Traditional annual planning and periodic training are no longer sufficient to bridge a gap this large. Leaders must treat continuous learning and the unlearning of outdated models as a rigorous operational feedback loop. Leadership teams use immersive learning journeys to reach a point of conviction where the strategic opportunity and the transformation pathway both become clear. A rigid leadership mindset is the single greatest point of failure for an otherwise agile enterprise. Survival in this era requires reaching the point of conviction, the moment when the leadership team fully aligns on the strategy and the execution path. This clarity is achieved only when continuous learning allows the top team to see the transformation pathway as an engineering reality, not a theoretical goal. When this threshold is reached, C-suite roles clarify and institutional resistance to change begins to dissolve. This shift in leadership psychology activates the 6 rewired capabilities, moving the organization to synchronized execution. The entire enterprise begins to accelerate synchronously, scaling new AI capabilities across every department at once. This synchronization separates leaders from the 70% of companies currently failing to realize value. In the AI era, technology is widely accessible, but organizational conviction and engineering depth remain rare. An enduring AI advantage rests on the depth of an organization's structural engineering and the speed of its continuous executive learning.